All right. Good afternoon, everybody. How are you doing? Can you guys hear me in the back all right? Okay. Okay, just yell at me if I ever get too quiet. I'm putting a microphone on, but I'll explain that later. It's not for the classroom. I'm recording these for you, so I'm hopefully can maintain projection, but especially early on, or if I get sick or something, I might struggle. So just a little bit of time getting to know you and telling you a little bit about myself. We've got about 100 people in here, so if you'd like me to know you personally, you probably better come to office hours, maybe sit up front, maybe engage with me, talk with me after class, things like that. I'll do my best, but I'm not learning every single. But I'll do my best. That's what I can tell you. All right, so I have a few slides for today and a few things just to talk about. This is probably for every course, kind of the way things will go for you. A few slides and a few introductory comments, tell you how the course is going. That's my plan for today. So I'd like to start, for those of you who have never set foot in an environmental engineering course before, to just kind of give you a big picture of what the class is about, what this field is about. So this is water and wastewater treatment, not just wastewater treatment. I understand that the syllabus or the course listing, things like that, it always just says wastewater. Well, we're going to do water treatment technology and wastewater treatment technologies and the principles behind them. A lot of them overlap. So what we're going to do in this course is build from kind of physical processes into chemical processes into biological processes. We don't really use too much biological in drinking water treatments. That's more of the wastewater section, so it'll feel like we're doing drinking water than wastewater. But a lot of the drinking water things also apply to wastewater. So it'll all be water and wastewater treatment in some way, shape, or form. So a couple things about what this class will feel like. You'll see me put on my funny little glove here so that I can write on my slides with you and provide notes in this manner. Now this means that I'm going to post these PowerPoint slides. Normally I'll try to have the slide set posted before class starts as a blank, so you're welcome to follow along, make your own notes, and then I'll post whatever notes I made onto Moodle later and kind of replace that file. So you'll have the notes here in written form. If I were you, I'd probably also take notes. That's just my own personal way of doing things. Keeps me a little busy if I'm listening to something. That helps me, but you'll have this as well. So that's going to be a resource for you. Okay, more about that in a few minutes. We'll take a look at the Moodle page I've got set up and all of that. So water and wastewater treatment, and in general, the field of environmental engineering, really we can summarize it all by saying it's about taking some stuff that's in some container of water. It's got some dirt. What we want to do is know the math to be able to design that process. Okay? So that means we're going to do a lot of mass balances on what is happening to the stuff given some amount of media, some amount of water or air or whatnot, and this class will focus on water. And it's going to be all about conservation of mass. Sometimes we will deviate a tiny bit and say conservation of number. Maybe we're counting how many pathogens are in the water. We don't really care to weigh them because a virus doesn't weigh much, but a virus could make you sick, or maybe it takes 5 viruses on average to get you sick. So we care about how many, but not necessarily the mass. So sometimes we'll say conservation of mass in terms of number, but it's the same principle. Okay, we're not going to make a virus out of nothing. So we're going to take overall conservation of mass principles to set up mass transfer and mass balance equations in order to solve how do we make our water clean. Okay, that's going to be it. So if you're scared, if I've already scared you about chemistry or biology or something, you can breathe a little bit of a sigh of relief, because even the chemistry boils down to this. We're just figuring out where the stuff is going. I'm going to give you a nice refresher. So those of you who just took my chemistry course or coming from chemical engineering, I'll talk more about this, but you can probably skip the next week, approximately, or just skim it, catch up like that. Because I'm going to give all the civil engineering students who have not touched chemistry since high school a nice refresher. Of course, if you weren't, not feeling super comfortable or want to see how I'm writing the chemical equations, you're totally welcome to be here, obviously. Okay, so we'll talk more about attendance and expectations in a few minutes, but just wanted to give you the big picture here up front. That's kind of what the class is going to be about. And we'll take a look, before we let out today, we'll take a look at one problem as kind of a very simple example of a problem which you could all solve today, but you're going to be equipped with a more technical method to solve it. It's a word problem, and you'll see how throughout the semester we're going to build on that and elaborate to equip you to solve more complicated problems that wouldn't be so intuitive. Okay, so I'd like to kind of set the course aside for a second and get to know you a little bit. And I used to use a fancy like Kahoot poll thing or some other software to get live feedback, but as all that technology developed, they started monetizing it, and I'm not paying a monthly subscription for doing this twice a year. So I'm going to do this the old school way and have you raise your hands, okay? So I have a question here. It says, what genre of environmental engineering are you most interested in? I've got 5 options. We'll go through them in a second, one by one, raising your hand. But I'm going to read them first. A, natural environment and remediation. B, global environmental challenges or policy. C, water quality and treatment. Obviously, that's the right answer because you know, just saying. D, air quality. Or E, not at all interested yet. I'm adding that yet because you don't get a choice. Okay, who's for A, natural environment and remediation? Okay. How about B, global environmental challenges and policies? C, water quality treatment? Okay, I'll convert a few of you, I'm sure. D, air quality? All right, we don't get to talk a whole lot about that this class, but some things are very relevant, and I'll try to mention that as sometimes we use water to treat air or vice versa. E, not at all interested. Okay, got some honest people here, but yet. Okay, how many of you didn't raise your hand for anything? Still not going to raise your hand, right? Okay, all right. And by the way, I'll just fill in a little bit about myself. So my formal preparation as when I was a student, I studied earth and atmospheric science. So I knew I was interested in water and the environment. The school I went to didn't have an undergrad in environmental engineering at the time, so I didn't even go engineering route. So for you civil engineers, I took a couple courses like this one as an undergraduate, but I never took any like structures or anything like that. So I am a different animal, and I appreciate that you guys don't have the chemistry background. So I'm gonna be sympathetic, and if you want to teasingly call me not an engineer, I'll accept scientist instead. But I did then do my PhD in environmental engineering, so I have that. All right, so I'm definitely water quality guy. I have a pretty good background in air from that program, and I've always been interested in kind of water and the natural systems. Shifted into water treatment for grad school. All right, so how old are you? I just turned 38 this summer. How many of you are less than 19? Anybody? Youngins? Okay, didn't think so. 20 to 21? Okay, probably half of you or more. 22 to 23? All right, anybody slightly older? Okay, cool. All right. Great. The first time I taught this course was my very first semester here. 2016 is when I started. And if you count, that means I would have been, I think, 29. So there was actually a couple of students that were my age or just older. And I think it was either this room or maybe the other room. So come a long way at this point. Okay, which topic are you least comfortable with? Again, I'll read them and then raise the hands. So unit conversions or word problems. That's A. B would be mass balances. C, chemistry. Or D, biology. All right, so who hates word problems? Anybody, or unit conversions? Forget your units all the time? Okay. What about mass balances? Maybe you never even heard of it till today. Okay. How about chemistry? How could you? And D, biology. Wow. Okay, so good news for those of you who are not liking biology. Really, the only biology we do is say, hey, this is how fast these things grow, and they eat the other stuff, and so here's some kinetic models. So we're just going to be using math to show the biology. I mean, even you could say that kind of about chemistry, but chemistry, we have to learn a little more chemistry than biology. So, all right, well, good. It's good to know. So, when you see this image, what does it make you think of? And I'm going to give you a moment to think through this one. We've got 4 options here. By the way, can you read this in the back? Is this big enough slides? Okay. And you could also bring it up, pull it up on from Moodle too. So the options are iron oxide, that's impossible. I think I've seen one of these at a state fair, and I hate chemistry. All right, so take a moment and then give me what you think is the best answer. That's what I'm looking for. Okay, here's some people are getting the joke. So I can kind of tell who knows enough chemistry to get themselves in trouble trying to count the bonds and things like that. And I heard the quote unquote right answer from somebody. All right, what do you think? Iron oxide? Anybody? Okay, there's iron there and there's oxygen. That's good. That's impossible. Anybody? Okay, some chemistry nerds think they're cool. Seen one of them at a state fair. Okay, we got like 8 of you got the right answer. All right, I hate chemistry. Okay, the other right answer. All right, so this is the reason I remember what ferrous versus ferric is. Those are 2 words for oxidation states of iron. So Fe2 plus is ferrous iron, Fe3 plus is ferric iron. This is a Ferris wheel, which is why you might see it at a state fair. Okay, so I remember this because my older sister gave me a t-shirt one time that looked a lot like that, just had Fe2 pluses around in a circle, and I was like, okay. And the shirt was like rust-colored red. I was like, perfect. It's like, okay, ferrous, it's rusty, iron, yeah, that's ferrous. So now I don't ever forget that. And maybe you'll have a chance at remembering now too. Okay, obviously there's no right answers. All right, so back to the course. I probably should have paired this with that first slide, but overall, water and wastewater treatment, there's these 2 topics. We kind of split the motivation based on what we need, right? Do we need to drink it, or do we need to make sure it's okay to discharge to the environment? Those are a bit different. Sometimes we clean water exceptionally well, and we have the capability of cleaning to the point where we could drink any source of water because we can technically separate just to H2O, right? We can do that with technology, but is it worth it? Is it worth the cost compared to discharging it, letting it go through the natural environment, and taking from a better source to drink, right? So we don't usually drink our wastewater, but there are some cases. If you think about life on the space station, for example, where do you get your water, or where does your water go? It's very expensive to ship water up to space. It's pretty heavy. So we're going to reuse every last drop perpetually as far as we can, right? So there are some situations where we might try to have more or less water reuse. So for water treatment, drinking that is, we have 2 kinds of standards. One is health, to make sure we are protecting our health. Those are what we might call mandatory or enforceable standards. And of course, I'm speaking kind of as far as the EPA is concerned. This kind of applies to many other places as well, but this is kind of how the EPA does it. Then we have aesthetic standards. How many of you enjoy drinking brown water? Anybody? Nobody? Okay, we got one person that was on the ball. How many of you have some sort of tea or coffee or beer ever? Or something. Okay, so a lot of you, did you enjoy it? So you do enjoy brown water. Okay, so you lied to me. All right. the thing is that whether or not it's brown is somewhat of an aesthetic standard, right? If we're making tea, maybe green water, if it's green tea, you're coloring your water, but you're okay with that. We're not so okay with that if it's coming out of the tap, because we think that probably means there's something bad in the water. We didn't want that there. Aesthetically, that's pretty gross. We don't want to drink our water if it turns orange because there's some sort of, rust getting knocked off the pipes or something. We kind of know something's wrong. Even if that iron oxide might not cause any health problems, maybe something else happened and, there's bad stuff there. Maybe there's lead on the pipes that got kicked off. Okay, so there's aesthetic standards that are not enforceable but recommended, we'll say, by the EPA. And these include more than just the color. It can be taste. You can have something that doesn't taste great but is health-wise it's fine. For example, it could also be odor, which is related to taste. If you've ever had well water that tastes a little bit sulfury, a little bit like, kind of smells like rotten egg sort of thing, that's hydrogen sulfide. That's at low levels, it's fine. But we are extremely sensitive to it because at higher levels, it's very toxic. So it's not like a toxic type of thing that will give you trouble with small levels. It's if you reach a certain threshold, it's bad news. But that's a very high threshold compared to where our noses can sense it. So we're very sensitive to it, but it's not technically a problem when it's there in the small quantities. So that would be an aesthetic standard. Okay, wastewater treatment, it's a bit of a different ballgame here because what we're aiming to do is, first of all, be able to discharge wastewater. We all want to be able to use the toilet, let's say, or perhaps run an industry that is washing something, using some sort of processed water, and then be able to discharge that in a way where we are not destroying the environment, or that we are controlling and protecting the environment from what we are doing. So maybe we are okay with building a certain area, maybe taking some land to have a stabilization lagoon and saying, okay, here's our treatment plant. Yes, we destroyed some environment, but that's so we can protect whatever comes after, right? So we're going to do this balancing act between protecting ourselves from the environment and the environment from ourselves. That's kind of the whole environmental engineering thing. So we want to protect intended uses. We want to make sure it's okay to fish, to swim, to boat, to do our recreation, to use it as a drinking water source, potentially. And really, rivers should not be flammable. So we'll talk more about that later. There's some pretty crazy examples. I don't think I brought that slide with me this time. But I'll show you some examples where that used to be a problem. When we get to kind of the wastewater treatment, if you discharge too much oil and grease, it turns out it separates and floats on the water. And if you get enough of it, it could potentially catch fire. How do you put that out? It's a good question. Okay, so those are our standards for wastewater treatment then really pertain to, okay, what kind of wastewater are we talking about? What kind of impact would it have on the water we're discharging it to? Where are we discharging it? Technically, there are some groundwater, some subsurface discharges. I have more experience dealing with surface water discharges. So is it going into a lake, a river, a tiny stream? Is it the stream itself and it would have been a ditch, during the dry season or something? What's going on with that and how are we managing it? Okay, of course, logistics. We have a book. Practically speaking, it's not mandatory for you to get it. I'm obviously providing a lot of course materials for you, but I do recommend it if you're at all interested in the field or think you might want a entry-level reference for it in the future. It's called Environmental Engineering and Science, so Introduction to Environmental Engineering and Science. It's a little dated by now, but it's just a really nice, accessible, readable resource. Okay, so it goes through more than just water and wastewater treatment. In fact, we're just kind of focusing on a few chapters that are dealing with that, but it'll give you some chapters on air, chapters on the mass balances, unit conversions, things like that. So if you're at all interested in that, I do recommend grabbing a copy at some point. if you're finding that you're really loving the course or struggling with the course or something, maybe get a copy or share a copy with some people and dive in. I'm not here to tell you must get it, but that's my take on that. We will have 2 midterms and 1 final. I've put up a tentative schedule on the syllabus already for that. We'll take a look at that in a moment. And the final exam, I think, is LSU already scheduled. I'll double check when it comes closer to time, but that should be the time slot already booked because they already scheduled that this far in advance. We'll have 4 homework assignments, and these will essentially cover the first couple weeks of class. This will be just this chemistry refresher, some units and mass balance kind of stuff. Then a second one before our first exam. This will be sedimentation and coagulation. So these will be 2 kind of smaller assignments. This will cover basically the majority of the physical processes. And then we'll get into stuff that deals with more chemistry and chemical level processes. Now, filtration, specifically membrane filtration, kind of does a little bit of both. So we will find that crossing these 2 points, we are transitioning from kind of a chemical to a physical, large stuff, to chemical, smaller stuff. We'll kind of deal with a little bit of both there. So then our first exam will be essentially here, if we wanted to write it that way, covering those 2, and then we'll have exam 2, and then the final. That looks like a question mark. Okay, now the first exam will be kind of the physical processes, sedimentation, coagulation, probably flocculation with that. We'll talk about it. Second one will be filtration and disinfection, so more of the chemistry stuff. And the last one will be this biological treatment. It also calls back to some of the sedimentation and other processes. And with this one, we will have the final exam. It'll be halfway comprehensive. The whole course is kind of comprehensive in the sense that all of these segments apply. We can disinfect wastewater, for example. We often do. So in that sense, it's sort of logical that it's comprehensive, but I'm going to say it's 50% comprehensive, meaning calling back specifically to exams 1 and 2, and then 50% the biological treatment kind of section. So that's what you can expect. I think that's approximately what's written in the syllabus. The homeworks, I decided a few years back, at some point, my solutions, my homework assignments are out there. I like to provide you with a lot of information, like to provide you with my slides, the lectures, and everything. And I'll show you all of those resources in a moment. But in so doing, pretty much all of my solutions for my standard homeworks are out there. And so either I was going to spend every semester making new problems, grading new problems, and all that, or I would let anybody who's cheating and using the old solutions, they would get the benefit, and the people who are working hard and trying it on their own were getting penalized. So I did away with all that and said, look, be adults. These homeworks, I'm only going to grade for completion. So it's up to you to learn from them. You just simply need to submit something that's showing work, showing that you've made an attempt and you found some sort of answer. You could be copying old solutions. I'm going to use the same exact homeworks that I've used in the past. If I modify them, I'm still not too concerned if how you came about your solution, but be an adult. Use it as a study guide, use it as something that says, hey, can I solve this problem? Do I know what's going on here? And I change the exams all the time. And so the consequence of doing it this way is easier homeworks, but my exams tend to be on the challenging side. I never aim to make them overbearingly challenging, but I want to challenge you there to make sure that you've learned this stuff. Okay? So that's my deal for you. That makes it a little more chill in terms of the homeworks, but you will find that the exams are going to stretch you a little beyond what we do in class. I want to make sure that when we learn a mass balance, then you could apply it to something we didn't specifically talk about. you know the reason behind why this mass balance is working, right? You will see some things that are exactly what we did in class and some things that stretch you a little further. That's kind of what you can expect on the exams. If I make a mistake on the exam and make it way too hard, I'm going to curve it. But with this course, this is the course I've taught the most since I've been here, so hopefully it'll be kind of smooth, and I usually know what to expect by now. Okay, if we go to the syllabus, which we will do, let's just go ahead now. You will see that for the grades, and I'll skip back up in a minute, we have, so homework, that's 50 points out of 400, and class participation. This is a value that if I get to know you, I see that you're participating, I can always increase it. I'm also going to try something new this time, new to me, which is to use Moodle's attendance deal. So we're going to try that in a couple minutes. We'll come over to Moodle and give that a shot. It might not work, and I'm not going to bother really taking full attendance until the end of the drop ad, so the roster is set, plus that gives me time to give the chemistry review. So, you know, like I said, if you peace out for a day or two because you just had my chemistry course, that's fine. I'm not bothered. Okay, so the point though is that whatever type of participation grade, I will probably give you a quiz or two. I'm gonna put at least one, maybe two reading assignments. Here's one of them. I remembered I included it here. And we'll have a Moodle quiz that'll just have a deadline. You have to take it. This will just be kind of encouraging you to participate in the class slightly beyond maybe showing up and, you know, participate, you know, just sitting here in class, right? Okay, so that's kind of my expectation for that category. We'll come back to this problem in a few minutes. So far we've talked a lot about the general topics of the course. I've listed my office hours. You're welcome to make an appointment, but my default is going to be I'll be in my office 1 to 2 p.m. on Mondays for you guys. So feel free to send me an email. Of course, class is here. There's also another option. So this will tie into the attendance part because some of you will inevitably have to miss or decide to miss or whatever. And I'm actually going to be pretty lenient. I am going to aim, if the attendance thing works, to give you credit for being here and participating live. But if you ever cannot, I'm live streaming. So since COVID, I just started live streaming my lectures, and I decided to keep it. I like it a lot better than Zoom if we're ever doing that. So if I pull up another tab here, you can find, I have a page here. It's youtube.com/@snowslab. And if everything's working like I think it is, we'll have some video inception here. Like I think it is, we'll have some video inception. So you can see, like I think it is, I'm sitting there and doing all this, right? And it's going to make your brain hurt if you watch too long. So let's not do that. You also see I have just a little spot for my webcam. That's why you see a little section down here. I'll try not to write in that little spot. It's just a little indicator for me because that's where I put my face, right? So that's why I have a mic. And occasionally you'll see me fuss with some things off camera. Essentially what's going on, let me fix this and I'll show you what I'm actually looking at over here. This will also give you some headache, if I can get it to drag over. There you go. So this is what I'm looking at. So if you were on YouTube and decided to talk to me, I'm going to see it over here. So if you are having to attend from home, you can write to me and ask, hey, what's up with that? What's going on? So that's a resource for you. That will be these recordings. I'll be posting on. Well, they'll be there on the YouTube page. Another thing you'll notice is I have set the link. Of course, I also occasionally confuse myself where my cursor is. At the landing page for our course, you'll see we've got the syllabus. I'll talk about these in a second. I also have this YouTube playlist. So if you open this link, it'll bring you right to that where I put the videos. Now, I have 2 courses that I'm teaching this semester, so if you log in and you suddenly realize this stuff is way over my head, I don't remember talking about this, maybe that's the grad version of this class that I'm teaching at 3. So there will be a playlist for each. If I'm on it, then I'm going to mark each 3110 or 7101, distinguish them. But it might take me a few days before I designate, okay, this video is in this playlist. So just go to the YouTube page itself. There will be that live section from past recordings. It'll be there. So even if I have not yet put it into the right spot, it's there. Okay, so it'll be accessible as soon as right now and as soon as I turn this off. So just wanted to say that's a resource for you. That'll also make it really nice for when I give you an exam review or something, or go over an exam. If you want to learn from it, there's a resource there. Okay, and I happen to know that I can see the numbers, and I see every time we are about to have an exam, there's certain videos that get a lot more views, right? Which I'm happy for, because that means you're using it to study, right? That's what my aim is, to give you the resources to learn what you need to learn, and to test to make sure you learned it. Okay, so that's a little bit about the course. Back to the syllabus. Kind of talked about all that. The grading, each exam is worth 100 points, and then the combination of the homework and participation attendance will be the last 100 points together. Grading scheme is standard. Talked to you about homeworks already. I'm just going to collect these all online. I probably will have a TA that will help me grade them for completion. It's not something that takes a super long time. I might have her help me with a couple exams as well. And she might proctor, I think the exam in October, I'll be gone for a week, so she might come in and proctor that exam for me. Probably give you a guest lecture at a topic as well. Okay. Talked about participation and attendance. Like I said, I'm kind of learning the Moodle attendance thing. If it doesn't work, we'll basically do it through Moodle quizzes instead. And those will be asynchronous, so it'll, again, just kind of be up to you to make your face known to me if you want to make sure you're getting full credit for being here and everything, or just risk having, missing quizzes and not getting any credit. But you should be all right. It's not a matter of trying to penalize you for any of that. Okay, I kind of walked you through already the way the course is going to flow. But if you wanted to look a little more particular, here's my plan for what we're covering when. So we're going to start with today, then we're going to do some units and mass balances next time on Thursday. Then chemistry refresher. So on Thursday, if you're not familiar with units and mass balances, reactions and reactors, maybe Thursday and next Tuesday are good to be here for those. So if you're comfortable with chemistry but not comfortable with those, check the schedule here, and then maybe a week from Thursday, you could probably skip, because if you're a whiz at chemistry, right? Because that'll be a review. Specifically, it'll be a lot of chemical equilibrium and learning kind of that stuff. From there, we can launch into our drinking water treatment processes, go into some of those physical processes, have our exam, go from there into filtration and disinfection, another exam, and then get into our biological treatment, wastewater processes. All right, I've been talking a lot, I feel like, and it's only been half an hour or so. Any questions so far? Feeling all right about it? Okay. If you ever do want to ask a question but you don't feel like raising your hand, you could actually log in, just mute your screen and type it to me. I would see it. So feel free to do that. Occasionally I'll have some random bots or other people join in the chat, and usually not too distracting, but sometimes a little strange sometimes. So there was somebody commenting on chemistry last time that was just, I don't even know what country he was from, but he was asking about it and was in an advanced high school chemistry class, I think, or something, and was like, why aren't you doing it this way? And it's not what I'm teaching. But maybe I should, I don't know. Okay, so to Moodle, let's take a look at the introduction section here. This is kind of the course, what the course is about. Of course, the syllabus is here. I'm giving you formula and tables for the exams, so you can see what's going to be on exam 1 here. That'll make a little more sense once we cover them, but one good study tip is to take a look there and see, do I know what each of these variables means? Could I use this in a problem? Do I know when to use it? Right? So when you look at these equations that I give you, and you'll also see I give you tables and stuff. We'll talk more about it as the course goes and during our study, our exam prep sessions, but it's a good resource. Next up, we've got these practice problems. This is a listing, so again, if you are feeling like you need a little more help with what kind of problems to solve, or just needing a little more resource for the course, this is my suggestion, is to get the book, right? There is an international version of it, but the numbers and the page numbers and problem numbers do not sync up. And I wasn't able to get an online copy or an electronic copy from the library. So if you get that one, it's probably still helpful, but the book listings that I have listed are not directly helpful in terms of matching. So you'd have to find those, yeah. This will be an Excel sheet that says, hey, problem 5.2. I didn't go through and scan every problem for you, so you will kind of need the book as a reference, or but again, maybe split a book with 5 people and it's $20 each or something, I don't think so. But there are a lot of good example problems, even the one right here. It gives a lot of good example problems like this one, and then gives you the solutions right after. And I have taken exam questions from those before and just tweaked them a little bit, right? So these are the types of things, like if you find something like that, it's like, oh, okay, can I solve this? It's pretty helpful. Yeah. Do you feel like the problems that we do in class and homework would be sufficient for exams? My hope is yes. Now, inevitably, I get some students that feel like no. So there will be some of you that feel like I was not prepared for that. Some of that will be on your own side, preparation-wise. Some of that will be, I did stretch you beyond specifically what we learned. If I'm ever making a course where there's 0 people that did better than a 96, especially in the class this size, I've done it wrong. So really, everybody, every time I teach this class, there are people that can get every problem exactly fully right. But having said that, if you are struggling with certain components, that can compound and it can be like, oh man, I really don't have any idea what I'm doing. So my suggestion is to try to make sure you're comfortable with how we build the problems more so than specifically what that equation ended up looking like. I'll try to explain that more as we go. You'll see it a little more when we say, oh, we can derive a mass balance in this way. Can you do that with a slightly different system? That's really one of the skills that I'm trying to teach you in this course. Does that help? Okay. Any other questions on that? All right. So again, we've got the playlist here. Of course, that I need to go and manually tell it, okay, this video is in that playlist, and I do that typically on Thursdays after I teach my classes, or maybe Friday if I forgot. And sometimes it's been a week and a half since I've done it. But they're all there under the live section. So you can always find them, and we'll do that. You can't see it on your Moodle, but you can see here, I posted the link to the last exam recap, stuff like that. I don't use this as little announcement things. I'll just email you through Moodle if I need to make an announcement, so you can ignore that. Every time I'm in here, I delete it, and it just comes back. So that'll be back. Okay. So that's kind of the landing page. I'm going to, in a moment, attempt to take attendance through this the first time. We'll have assignments and solutions for them here. I went ahead and posted homework 1. This will be due on the beginning of class on September 23rd. I'm going to double check that to make sure that's not our first exam date. Yeah, that should be due earlier. Sorry, I'm going to fix that. Because we'll have 2 smaller homeworks, I think. Yeah. So I'm going to tweak that. It'll be due a little sooner, but again, that's for completion. To the extent that we do some quizzes, they will be here. I'm not going to put all of these up, but I pretty sure will do the cryptosporidium quiz. That's that reading assignment. It's an infamous outbreak of a diarrhea-causing disease. It actually causes a lot more problems for people that are already immuno-challenged or immunocompromised. So that it did actually cause a lot of deaths. This was an outbreak that occurred associated with an issue with some drinking water treatment. And so the quiz is kind of checking, hey, did you take a look at this paper? Did you kind of get the big picture of what went wrong? And we'll talk about that when we get to the disinfection section of our course. So we're going to have mostly quizzes like that might cover something like granular filtration, right? Now, if the attendance module works perfect and great, maybe we won't have many of those unless you like that. And I'll just take some attendances every day. But we'll navigate that, and it's not worth a whole lot of your grade. And if I ever do anything, I'm just giving you credit. So that's my default. That's not the point is if I can see that you are participating and I've had some way of seeing that, my bet is that you've learned a little more, and therefore I'm giving you credit. Okay? And if I made a mistake, it's not on you. I'm not penalizing you for that. All right, so section 1 and so on. Each of these will have our kind of learning categories or lecture categories. You'll see here the slides. This will be a blank copy of what we're going through. And then Thursday's slides are here. I need to go through and update those, clean them up from last time I used them and change anything I want to. And then I'll make them live and you'll have them for Thursday. So every time we'll be doing this. And if I forget, just remind me, hey, can you post those slides? I know some of you will end up liking to take notes on them. And yeah, well, each section will be populated over time with the different, the chemistry and all that as we go. All right, any questions on that? All right, so I think I should. Let's see if we can do the attendance. All right, give this a shot. See if that works, and you tell me how it goes. Zoom out. It's not letting me zoom out. Hang on. Yeah, because the edge is catching it, right? It's yeah, it's just not showing the hang on. There we go. But then the left edge also cuts it, right? Does that work? That worked? Okay. Now does it? So it's scanned, but it's giving you an error. Did you do it for the right course? So this is the course, but I haven't set up groups yet. And when I was learning how to do this, somebody mentioned you should set up groups because it's good. And I was like, I don't know what that's about, so I'm not gonna do that yet. So I'll set up groups for next time, and I'll try it again on Thursday. And for now, so we'll say, I'll say this. For this time, definitely next time, let's actually just go take a look at the syllabus. Until we start, let's say until this date, 9/9, it's not gonna count for or against you when I take attendance. We're gonna have some trial period, And then by this time, this is when I feel like for all of you chemical engineers who've already done tons of reactions, reactors, chemistry stuff, you can start showing up again here, and I'll care. we'll say it that way. I encourage you to be here. Maybe you learned something anyway, or it's a good review. But that's when, for whatever attendance we figure out, we'll have it going. But I will try again on Thursday to check to make sure that we're good. All right. So I think that's pretty much it for Moodle and the syllabus. Whoops. Let's take a brief look at this problem. Back to Earth for a moment. I'm going to read the problem, let you think about it for a minute, and get a little feedback from you about how you feel about solving it today without learning anything from the course aside from, hey, it's mass balance stuff. So the problem says we have a stream flowing at 10 cubic meters per second. It has a tributary feeding into it with a flow of 5 cubic meters per second. The stream's concentration of chloride upstream of the junction is 20 milligrams per liter. The tributary has a chloride concentration of 40 milligrams per liter. Treating chloride as a conservative substance, that's just telling us we don't have a reaction happening. We'll get into reactions later. It could complicate our mass balance. But treating it as no reaction and assuming it's completely mixed when they meet, find the downstream chloride concentration. So think of, how many of you feel like you could do it in like 2 minutes? Anybody? Okay, a few people. So honestly, this is a problem that I hope that all of you as engineers comfortable with math, once you've learned what this is talking about, you'd be like, oh, yeah, I can do that in 2 minutes. But it totally makes sense that you're not there right now because this is a kind of a weird sounding problem. In a way, it's, how do I say this? It's two variables. It's like 2x plus 3x equals question mark x. It's that type of a problem once you set it up in the right way with the mass balance. So it will become very simple for you, but this is the way a lot of our word problems are going to look. So we're going to hopefully get our math to the point where we can say, oh, okay, this is how we put these problems together and solve for the solution. So we're going to start there next time and kind of give you that solution. Feel free to try this on your own time and kind of get a feel for what is this talking about. All right, so we'll see you on Thursday.